In this video, we're going to discuss the relationship between elasticity and revenue, the three types of elasticity, and how to find maximum revenue using the elasticity function. Let's get started. Let us first recall the definition of the elasticity of demand, E, at a unit price x. So given by this E of x, which is equal to the negative of x times the derivative of the demand function over the demand function d of x. Now, to see the relationship between revenue and elasticity, we need to look at the derivative of the revenue function. But first, how do we find the total revenue when the unit price is X? So the total revenue can be obtained by taking the product of the unit price X and then times the quantity demanded, which is equal to Q, or that is denoted by D of X. And now let's compute the derivative of this demand function. So by using derivative of a product, we'll get here derivative of revenue function is equal to, we may take first the derivative of the first factor, which is equal to 1 times, just copy the second factor, and then plus copy the first factor times the derivative of the second factor. So that is derivative of d of x. Now, to produce the e of x here, okay, we have to factor out a d of x. So factoring d of x from this first product, so we'll be left with a factor 1. Now this product here, x times d prime of x, can be written as a product of d of x times this one. So as you can see, when we multiply these two, so this d of x cancels out. So we'll be left with x times d prime of x. And this fraction here is actually the negative of our elasticity function. So it's the negative of this, so that is equal to negative e of x. Then, assuming that this demand function is always greater than 0, then we'll get the following relationship between elasticity and revenue. First, we have if the elasticity of demand at the price x is less than 1, then that means that the value of this one is less than 1. So this 1 minus e of x here will be positive. It will be greater than 0. It's like 1 minus a number less than 1, like 0.9, you'll get 0.1, which is a positive number. And multiplying it with a positive demand, then we'll get a positive product. So therefore, the derivative of the revenue function is greater than 0. And what does this mean? It means that the revenue R is increasing at the unit price X. Now, how about if the elasticity of demand at the price X is greater than 1? Then if it is greater than 1, then this part here is greater than 1, and if you subtract a number greater than 1 from 1, the result will be a negative number. So it is less than 0. And multiplying it with a positive number, you'll get a negative product. So therefore, the derivative of r of x is less than 0. And what does it imply? It implies that the revenue r is decreasing at the unit price x. Lastly, if the elasticity of demand at the price x is equal to 1, then we can conclude that the revenue is maximum at the price X. Let us illustrate these relationships between elasticity and revenue using a graph. So if our x-axis denotes the unit price and the y-axis denotes the total revenue, then this means that when the elasticity of demand is less than 1, the revenue function is increasing. And then when the elasticity of demand is greater than 1, then the revenue function is decreasing. Therefore, we conclude that if the elasticity of demand is equal to 1, then the revenue will reach its maximum. So one way to find the unit price that maximizes revenue is to find the price x, let's say x of 1, wherein the value of the elasticity function is equal to 1. So we can find the maximum revenue using the elasticity function without using any maximum and minimum principle, such as the closed interval method or the first derivative test or second derivative test. Now let us discuss the three types of elasticity. For a particular price X, we say that the demand is inelastic if E of X is less than 1. And this implies that the revenue is increasing at X, which means that a small increase in price will result to an increase in revenue. Now, if E of X is equal to 1, then we say that the demand has unit elasticity at the price X. And at this price, we say that the revenue is maximum. And third, if E of X is greater than 1, we say that the demand is elastic. And for this case, we know that the revenue is decreasing at X, which means that a small increase in price will result to a decrease in revenue. So these three types of elasticity of demand is illustrated in this graph. So typically, the demand function is a decreasing function. And then when E of X is less than 1, we say that the demand is inelastic. And when the elasticity function is greater than 1, then the demand is elastic. And when E of X is equal to 1, we say that the demand has a unit elasticity. And when the demand has unit elasticity, then we'll get a maximum revenue. Let's have an example. Suppose that for a certain product, the number of units demanded Q when the unit price is X is given by this equation. Q equal to D of X equal to 120 minus 20X. Let's find the elasticity as a function of the unit price X. And let's find the elasticity at X equals 2 and at X equals 5 and determine the type of elasticity at each price. And let's interpret our results. And lastly, let's find the price that gives the maximum revenue and find this maximum revenue. Let's solve this problem. So our elasticity function E of X is given by negative of X times D prime of X all over D of X. So this is equal to negative of X and D prime of X from this one. So its derivative is just equal to negative 20. So this is negative 20 over D of X. So that is 120 minus 20X, okay, which is equal to, we can put the negative sign here in front of X. So that becomes negative X times negative 20. So that is equal to 20X over, we can factor out the 20 in the denominator and write it as 20 times 6 minus X. And canceling the common factor, we'll get here X over 6 minus X. So this is the elasticity as a function of X. Now let's move to problem B. So let's find the elasticity at X equals 2 and X equals 5. So again, E of X is equal to X over 6 minus X. So we'll get here E of 2 at X equals 2. So this is equal to 2 over 6 minus 2, which is equal to 2 over 4, and that is equal to 1/2. Since the elasticity at the price 2 is less than 1, we conclude that the demand is inelastic at this price. Also, this means that the revenue, okay, is increasing at X equal to 2. So if we increase the price by a small amount, then we would expect that the revenue will increase. Another interpretation of this elasticity function value, as I discussed in my previous video, is that if we increase the price by 1%, we would expect that the demand will decrease by just 1/2%. So that is another interpretation of this elasticity value. Now, when X is equal to 5, so we compute for E of 5. So E of 5 is just equal to 5 over 6 minus 5, which is equal to 5. And since this is greater than 1, we conclude that the demand is elastic at this price. And if we have an elastic demand, then at this price, okay, also the revenue is decreasing, okay, at this price. So at x equal to 5. And another interpretation of this value is that if we increase the price by 1%, we would expect that the demand will decrease by 5%. Let's now move to the last question. So let's find the price that gives the maximum revenue and find this maximum revenue. So we know that the revenue is maximum when the value of the elasticity function is equal to 1. And we have computed already our elasticity function. So we have here x over 6 minus x. So this must be equal to 1. And to solve this one, so we just have to cross multiply. We have here x equal to 6 minus x. That is the same thing as multiplying 6 minus x both sides. And we'll get here 2x equals 6. And we'll get x equal to 3. So therefore, this is the price. This is the price that maximizes the revenue. And now, what is the maximum revenue? So the maximum revenue is just the value of the revenue function when x is equal to 3. But how do we compute for revenue again? It is equal to the unit price times the quantity demanded, which is the same thing as our d of x. So we plug in the value of x here, which is equal to 3. So this is just a 3 times d of 3. And this is equal to 3 times d of 3 is 120 minus, using this one here, 20 times 3, so that is minus 60. And that is equal to 3 times 60, which is equal to 180. So if the price is in dollars, then our maximum revenue is $180. And we can realize that maximum revenue if the unit price of our product is equal to $3 per unit.